So to kind of do a little sum up of what we were doing before, let's say we look at number 86 in 18.5, so we're still in 18.5, and let's say that I ask you for let's look at 85, and I ask you for the perimeter. Now this is a rectangle, right? So what's the perimeter of a rectangle? Two lengths plus two widths, right? What is perimeter? It's the length around the outside. You guys agree? So you're going to cover a width, a length, a width, a length, right? So what is the length of this? Okay, if you guys choose this way, that's fine. It's not 40 though, it's square root of 40, so that's 2 times square root of 40, plus what's the width?
2 times 3 square root of 2.
2 times 3 square root of 2, right? That's 2 times width. You guys agree? So that means we got 2 square root of 40 plus 6 square root of 2. You guys agree? How do we multiply square roots? Outside times outside, inside times inside. So 2 times square root of 40 is just 2 square root of 40. And 2 times 3 square root of 2 is 6 square root of 2. You guys agree? Am I done? What can I still do? You can break down 40. What does 40 break down into? 4 and 10. That one's pretty easy. Which is 2 and 2 and 2 and 5. You guys agree? So, what do I need to bring out of a square root? I need squares. What do I have square of? 2. So if I bring a 2 out, that means I actually get 4. And what's left on the inside? 2 and a 5, so 10. Plus 6 root 2. And this would be units.
So the 6 square root of 2 is stay like that?
Yes, 2 is just 2. Nothing more we can do there. It's not a square. We can't do anything. And in fact, are these like radicals? Nope, then that's it. Walk away.
Only like when it's the same number of the radical sign.
Indeed, you have to have the same radicand and the same index. So this would be the perimeter. So I mean that could be in feet or inches or centimeters if you're Canadian, whatever. What if I asked you for the area? What's the area of a rectangle? Base times height or length times width. It's the same, right? So what did you guys tell me the length was? Square root of 40 was your choice, which made the width 3 square root of 2. You guys agree? And so how do I multiply them together? What do I get? Yes, 3 square root of 80. Right? Outside times outside, inside times inside. So that means a 1 times a 3, and then on the inside 40 times 2. Everybody remember? That was a long week for you guys. But then what do we do?
Break down the 80.
Yes, indeed. 80 breaks down into, yeah, 8 is 2, 2, and 2. 10 is 2 and 5. You guys agree? So bring out the squares. What do we got? Yeah, we can bring out 2 twice because I have 2 pairs, 2 squares. So that's going to be 12 square root, and then we still have a 5 left under. And this would be square units, right? Feet times feet are feet squared. So it would be square feet, square inches, square centimeters, whatever. Right? That's how area works. Are you guys okay with that? A very, very rudimentary application of what we've been doing, but there it is. All right, so we had done adding and subtracting in 18.4. We did the beginning of 18.5, which was multiplying these monomials together. But we can level up. Let's say I want to multiply square root of 5 times 2 square root of 2 plus 1. So I'm multiplying these together. Now what does this look like to you? Sort of. It's the opposite. Distributing. Yeah, unfactoring, if you will. Right? It's like distributing this through. And that's indeed exactly what we're going to do. We're going to multiply that square root of 5 times the 2 root 2. And then we're going to multiply the square root of 5 times the 1. So we wind up with 2 squared, mumble, 10, okay, plus 1 square root of 5, right? And the 1 is understood, so we can just write square root of 5. Do you guys see what I did there? Just distributing? Anything simplify? Right? 10 breaks down into 2 and 5, but there's no squares in that. So that's it. We might do two square root of 3 times square root of 5 minus 3 square root of 6. Once again, we will distribute. And that does, as you say, give me 2 square root of 15 minus 6 square root of 18. Let me see some neck action. Do you guys see how that happened?
Yeah.
All right. So remember, how are we multiplying these together? Outside times outside, inside times inside. So when I distribute, that's going to be a 2 times a 1, which is 2, and then that's going to be a 3 times a 5, which is 15. So there's the 2 and there's the 15. Does that make sense? Then, when I distribute to the second term, what am I multiplying together? The 2 and the 3, which is going to give me the 6.
Oh, the 2 and 3.
And then we're going to do the
You're
3 and the
putting 3 and
6,
that's why I'm doing that.
which gives me the 18.
I blame you.
Well, I can take it. Are you okay, though? Does that help your question a little bit? Yeah, this time we can simplify. 15 just breaks down into 3 and 5, but that doesn't go anywhere. 18, however, is 9 and 2, where 9 is 3 and 3. So indeed, we do have a square there, which we can then break out of the square root. So I have 2 square root of 15 minus 18 square root of 2. You're almost there.
Oh, I see.
I was like, keep going, keep going. You're almost there. Yep, so we have a pair of 3s. So we have a square of 3s. We can bring a 3 out. It kills its square root, but the 2 we do not. So it has to stay under. And they're not like radicals, so that's it. Is that okay? What if I give you 3 root 2 times 6 plus 3 root 10? I want you guys to kind of take the reins. Maybe some of the more uncomfortable people. Right? Somebody want to tell me kind of what you think? If you're really confident, maybe take a back seat for a minute. What do you think?
I would say 18 square root of 2.
Do you guys agree? 18 square root of 2 is right. What about the second term?
9 square root of 20.
So he's pretty good. Are all of you that good?
Is that right?
Yeah, I wrote it down, so that's a good hint. Do you guys see what we did? outside times outside. So we're distributing. So we're distributing 3 square root of 2. So outside times outside means we wind up with 3 times 6, which is 18. And we have 2 times 1, which is 2. Right? We have 3 times 3, which is 9. We have 2 times 10, which is 20. Yes? Is this all right? Is this okay? Right? Okay. But we're not done because square root of 20 does break down. 20 is, 2 and 10 is just as good as, 4 and 5 is another one, which is why I was about to write 5. 10 breaks down into 2 and 5. Right? Either way, 4 would be 2 and 2, and then 5. So you get to the same prime factorization. What can we bring out?
2.
We can bring out a 2. That means I wind up with 18 square root of 5. So 18 square root of 2, we couldn't do anything with that, plus 18 square root of 5. Can I squash these together?
Yes.
No.
No.
Why not?
Radical or radicand, they're not the same.
The radicand's not the same. They're not like radicals, right? This is like if I have 18 bananas plus 18 oranges. Well, that's 18 bananas and 18 oranges, right? It's not suddenly like apples. Right? I like fruit. It's just me. Okay, so what if we did the cube root
I knew it was going to start.
of y
Letter
times 2 cube root of y squared minus cube root of 9. Again, what am I doing here? Just distributing. So I wind up with the first term being,
2. This one.
that's good, that's a good start, 2 cube root of
Y cubed.
y cubed.
Ooh. Fire.
Minus, cube root of 9y.
Cube root of 9y. Oh, there we go, there we go. Starting to get that energy from you guys. Do you guys agree? Is this okay? Right, so we did inside times inside and outside times outside. That's how it works. So we get 2 cube root of y cubed, and we get minus cube root of 9y. Now, can we simplify?
You can cancel the cube,
The Y.
y cube
The
and
cube root.
So what do you get?
Y
Two.
cube root.
2y.
Oh, wait.
Right? What do you need to take out a cube root? A cube, which is exactly what we have with nothing left over, right? So we bring a y outside, nothing left under. So that's a 2y minus,
Isn't that a...
I think that's it. Minus 3.
what do you,
But see, they have a 1, so they have minus 3.
so in order to break out a cube root, I need a cube. Well, what is 9?
Nothing.
Right, it's 3 times 3, right? Which is a square, but that's not enough, right? And what is y? And it's just a lone y, so it's not enough. So easy it was hard.
It's 3 cubes.
Cube root of 9y. It's just cube root of 9y as is. Is that okay? What if we had... Oh, it's going to get worse.
I'm okay with 15 minutes of classroom time.
I promise it's going to get worse.
Before it gets better?
It's not going to get better.
Oh.
No, this is just all down, uphill. It's all uphill for you guys. Sorry. It's the way it is. Let's say we do a fourth root of 8x times 3 fourth root of 2x squared minus 2 fourth root of 4x cubed. All right, same thing. We're still just distributing a monomial throughout the binomial. You guys agree? So what do we get?
24.
No, it's always
3. Mm-hmm. Look at that. You were unconfident. Now you're just correcting your neighbor like, dude, you crazy.
Yeah.
So we do have 3 fourth root of
16x cubed.
16x cubed. So minus 2 fourth root.
No, 32.
32x to the fourth. I got you with the multiplication there, numbers.
Damn.
It's multiplication tables. 3 fourth root of 16x cubed minus 2 fourth root of 32x to the fourth. This is it.
8 times.
Now what?
Times 3 is 24.
Yes.
I don't remember the table.
Both of these break down. What do you got for 16?
2 and 8.
2 and 8's fine. 4 and 4 also works. Either way, you wind up with 2, 2, 2, 2.
So we got 3 times 6.
32 is, well, as we just heard, 8 and 4.
8 and 4, yeah.
8 is 2, 2, and 2, and 4 is 2 and 2, right? So what do I need to get rid of fourth roots?
4th cube.
Fourth powers.
Yeah.
Right? Fourth powers.
Apparently.
If 2 is square and 3 is cube, 4, they're quartic. All right? Yeah.
What? Can you say that
Quartic. Like cubic, quartic is
Quartic?
fourth. Yeah. Some English words you've never heard before. Right?
again? Quartic?
Like quarters, similar root. Yeah. Funny how that works like that. Right? See, math is easy. It's English that's hard. That's quint is the prefix. Quint.
Quintic.
Maybe I've never heard that word, but it goes all right. All right. So here we go. Do I have fourth powers in that first?
Yes.
What do I have?
2.
So I can bring it out. So what do I get?
6.
6
Fourth root.
fourth root of
X cubed.
x cubed. All right. I don't have enough x's to come out. I need a fourth power, and I only had a third power. You guys agree? What about in the second one? So if I pull out a 2, that's going to be 4, but what's left behind?
2.
A 2, but what else?
X to the 4th.
All right, if I have a fourth power of x, then I can pull out
Yeah. So
and have an x out front. None left under. So I have 6 fourth root of x cubed minus 4x fourth root of 2. Are they like radicals? Nope, that's all you can do. Neck action on that one. How are you guys feeling about this now? Feeling a little more confident? Feeling a little better about this?
not getting worse.
Well, next example.
In the class, still not bad.
Next example. What if we had square root of 6 minus 4 square root of 2 times 3 square root of 6 plus square root of 2? Now it's not a monomial on either side. It's a binomial times a binomial. All right, well,
That's foil, isn't it?
foiling out, yes. That's what we're going to be able to do here. So, FOIL. What do you have for your first?
3. 36.
Okay. The square root of 36 is 6. Now, we can skip that in our mind. If I'm doing a 6 times a 6, isn't that a square?
Yes.
And what happens to a square with a square root?
Yes.
It comes outside. So square root of 6 times square root of 6 is just 6. Is everybody okay with that? Your outers?
12.
Square root of 12. So plus square root of 12. Your inner,
Negative 12 and square root of 12.
you got it. Negative 12 square root of 12. And then our last, what's that going to be?
18.
Minus 4 times 2. Again, you can go through square root of 4. But what happens when you do 2 times 2? That's a square, right? And that cancels the square root. We got to be very comfortable with that for something we're going to do shortly. So it winds up being 18 plus square root of 12 minus 12 square root of 12 minus 8. You guys agree? Now, I want you guys to somewhat even be comfortable getting to this line. Right? Square root of 6 times 3 square root of 6, that's going to be a 6 squared, so that kills the square root, and 3 times 6 is 18. Right? Square root of 2 times square root of 2, that's going to make a 2 squared, which cancels the square root, so that's just going to be negative 4 times 2, which is minus 8. You guys agree? Do we have like radicals?
Yes.
Yes. So 18 minus 8
10.
is 10. Good confidence. And square root of 12 minus 12 square root of 12
12? Minus 11.
minus 11 square root of 12. Right? 1 banana minus 12 bananas means you're in debt 11 bananas.
Yeah,
Bananas
still-
didn't go
there's
anywhere.
an imaginary 1.
Yep, there's a 1 up front. That's why I like that example. All right? All right, just think of bananas or whatever fruit floats your boat. All right? 1 banana minus 12 bananas means you're in debt to some angry gorilla 11 bananas.
You don't break it down anymore.
So that's
We do.
11.
Right? 1 minus 12 is negative 11.
Right, and the 10 minus 11, can you do those two?
No, these are not like radicals. We cannot combine these two any further. But we can simplify because square root of 12, 12 breaks down. If you do 6 and 2, that would be then 2, 3, and 2. So we do have a square in there, don't we? So we can pull it out, and we get 10 minus 22 square root of 3. Again, are these like radicals? No. So you can't combine them any further. All right? Usually with this stuff, you guys do too much. You guys just start making stuff up. You start mashing your bananas into your oranges, and you get a fruit salad that nobody wants. What if we attempt 6 square root of 5 plus 3 square root of 2 times 2 square root of 5 minus 4 square root of 2? More foiling, right? So what do we get?
12 square root of 5.
So we get 12 times 5?
Huh? Square root of 25 is 5.
But again, I want you guys to think of it this way. 5 times 5 is going to be a square. And what happens to a square under a square root? It comes out. You guys agree? What is your outer term? Minus 24 square root of 10. Your inside term? 6 square root of 10. Your last? Minus 12 times 2. 2 times 2 would be a square, which comes out of the square root. You guys agree? So we wind up with 60 minus 24 root 10 plus 6 root 10 minus 24. And they're all like terms. They're all constants, but they're not all like radicals, right? Who are the like radicals?
24.
I can subtract 24 from 60. That's going to give me 36. And I can add 6 root 10 to negative 24 root 10. Those are like radicals. What's that going to get me? Negative 18 root 10. You guys on board? The remaining two terms are not like radicals. Can I simplify?
Yeah. Wait.
10 is 2 times 5, but those aren't squares. So this is it. You could, but I don't want to. And you're not expected to there. All right, so multiplying we got. Distributing we leveled up. That wasn't too bad. Foiling. All right, all right, all right. What else was out there?
Oh no. Trinomial factor?
Yes. Yes, you guys were expecting it.
Oh no. You just rocked your world over here. I'm gonna go home and do it. Stare at the wall for like 2 minutes.
We've got our special forms. We've got a plus b, the whole thing squared. Do you guys remember what that multiplied out into? No. Mumble, mumble. There you go. A squared plus 2ab
Oh, plus, always positive.
plus b squared.
Never mind. Sorry.
Perfect square thing.
That is our perfect square trinomial.
Different square.
And then we have a minus b squared, which multiplies into a squared minus 2ab plus b squared.
They're coming back. Why?
Indeed.
Ever, ever, ever.
And then we had our difference of squares, which I heard somebody say out there. A plus b, a minus b multiplies to a squared minus b squared. All right. So remember, when you have a plus b squared, it means you have a plus b and another a plus b. So the middle's going to double up. When you have a minus b squared, that's an a minus b and another a minus b. So the middle's going to double up. When you had a plus b and a minus b, the middle canceled out. And that's how we got our special forms. If you didn't make friends with these at the time, well, they're back. All right, wine and dine them again. And get to know them well. Their favorite color is purple, clearly. All right. Okay, but what happens when we square a square root? Yeah, it cancels out. So this is where this is going to start coming in. So let's take a moment and let's look at square root of 5 plus square root of 6, the whole thing squared. Who's playing the role of A?
Square root of 5.
Square root of 5. And who's playing the role of B?
Square root of 6.
Square root of 6. So what is A squared?
5.
Yeah.
Whoa.
Plus 2 times, what is A times B? Yeah, square root of 30. Plus, what is B squared?
36.
6.
Oh.
You could do square root of 36, but I want you guys to get really comfortable understanding that squares cancel square roots and doing that. Are you guys on board with this? Right? Shook, not shook. You guys okay?
Did you just say shut?
Mm-hmm.
Oh my gosh.
You guys over here?
Yeah.
I love you front row people. All right.
Yes.
You tried to invade the front row, but that's okay. We'll keep you. All right, so I have like radicals in the terms of 5 and 6, right? Because they add up to?
11.
Okay. So 11 plus 2 square root of 30. Does 30 break down?
I want to say no.
It's 3 and 10 is 2 and 5. But do I have any squares in there?
No.
Then that's it.
Wait, how did you get that last 6 over there?
B squared.
And the third. Perfect square. 695.
Okay.
Right? If you have that squared, that's going to cancel the square root.
Oh, to be 2 times.
I won't just do one example. We'll have more.
Yeah.
Like right now. It's good. It's good. You guys were a little shook at first, and then you got better with this. So let's do, say, square root of 3 minus 7 all squared. Notice that 7 is not in a square root. So our a squared is going to be 3. Then it's going to be 7 times root 3 doubled, which is going to be 14 root 3. That's your 2ab, right?
Mm-hmm.
And then your b squared is 49.
Oh, yes.
Right? A squared cancels the square root. Then a times b, well, outside times outside, inside times inside. That's just 7 root 3 doubled, 14 root 3. And then b squared is 49. There was no radical on that one. You guys okay there? Combine your like radicals and you get 52 minus 14 root 3. And root 3 doesn't break down. All right? We were learning these special forms way back when, and then we reversed them, and now they're back again. All right? What if we want to do 2 root 2 minus root 6 squared? She's not lying. What if I want to do this one then?
4.
So who's playing the role of A? 2 root 2. So what happens when I square that? Is the 2 up front underneath the radical?
Yeah.
No. Then when I square it, I get 4. The 2 that's under the radical, when I square that, what happens? The 2 cancels. Or I'm sorry, the square root cancels, and you just get 2. You guys agree? The outside 2 squares to 4. The inside 2, the square just cancels the root. That's your a squared. It is 8, if you're comfortable making that jump. Good, good. Then what do? 2ab, right?
Yes.
So multiply these together, and you get 2 radical 12.
Yes.
Double it, and you get 4 radical 12. That's your 2ab. Finally, your b squared is just 6.
If you doubled it, why is it so 12?
Because it's outside times outside. So if you have 2 root 12 and you multiply by 2, it's just the outside. That gives you 4 root 12. All right, this is good questions because I'm about to level up on your face.
Oh my.
All right? Karate.
Oh my.
All right, so what do we do?
Combine the 8 and the 6.
Yeah, so we got 8 plus 6. Hopefully everybody's okay with that one. You said yes, but you didn't answer. 8 plus 6 is 14. Very good. Minus 4 root 12. But 12 is going to actually reduce. That would be 4 and 3, where 4 is 2 and 2. So I do have a square still. So if I pull a 2 out, I get 14 minus square root of 3. Right? 14 minus 8 square root of 3. Are you guys with me on this?
Yes.
All right. So what if we have the square root of x plus 1 plus 2 all squared?
Is it 2 square root of x plus 2x plus 2?
We're going to start with x plus 1. Who's playing the role of a? Square root of x plus 1. So what's a squared? X plus 1, right? A square will kill a square off free and clear. So that's your a squared, right?
Plus 4?
No, not plus 4 yet.
Oh no.
You got your 2ab.
Oh, yeah.
Oh yeah.
So what happens if you do square root of x plus 1 times 2? Well, it's 2 square root of x plus 1. Outside times outside, inside times inside. So 2 square root of x plus 1, double it, 4 square root of x plus 1. That's your 2ab. Plus your b squared is 4. Now, just to cast shame on all of you, you guys just told me that 1 squared plus 2 squared is 3 squared. But is that the case?
No.
No. 1 plus 4 is not 9. Don't do that. All right? You cannot square term by term. That's not how it works. All right? Okay. So, what can we combine on this expression?
The fours? No. No, 5.
The 1 and the 4 that are by themselves.
5.
The radical is not like radicals with anything else, so it can't combine with anything else. And x is not like terms with anything else, so it can't combine with anything else. So we would have an x plus 5 plus 4 times the square root of x plus 1, and that's all we can do.
I don't like this one.
Yeah, but this is the one we're going to be using next class. So I'm trying to lead you up to it. Baby steps. What if we wanted to do square root of x minus 6 minus 7 all squared?
X minus 6
Yeah, the a squared would be x minus 6
minus 14 square root of x minus 6
minus 14 square root of x minus 6. That's your 2ab. Can you guys all see that?
minus 49
Not minus.
Plus 4.
Plus 49. That's your b squared.
Well, you did a negative and positive.
Yep. So, square root of x minus 6 squares to just x minus 6. Then, your 2ab. So you multiply them together, and that's 7 square root of x minus 6. Double it to 14 square root of x minus 6. And then 7 squares to 49. Is that okay?
Yeah, I was stuck now, I got it.
What are the only like radicals and like terms we have there to combine?
49 and negative 6.
Yeah, the negative 6 and the 49.
43. X plus 43
So I've got an x plus a 43
minus 14
minus 14 square
square root of x.
root of x minus 6, and that's it. That's all we can do with that. Sometimes the hardest thing you guys have here, walk away. Right? You guys just make rules up so that you do more work, so that it feels more complicated. Right? Math is not complicated. It's perfect. What if we had 2 minus square root of 3x plus 1 all squared?
4
Yeah, we'll start with 4.
minus 4 times the square root of 3x plus 1
Minus 4 times the square root of 3x plus 1. Do you guys see where that came from? What is that?
2AB.
It's your 2ab. Yep. And then
3x
plus 3x plus 1, that's your b squared. Is everybody okay? Once again, the only terms that are actual like terms and like radicals are the 4 at the very beginning and the 1 at the very end. So I could write this as 3x plus 5 minus 4 square root of 3x plus 1. Now if you wrote 5 plus 3x, nobody's going to slap your wrist over that one. But we do get these 3 terms, and that's it. Let's try one more. Let's try one more. What if we have 2 square root of x plus 8 plus 3 all squared?
4 x plus 8
All right. So when I do my a squared, the 2 is not under the radical, right? So it actually squares to 4. And the square root of x plus 8, when you square it, comes out free and clear. What's next? 12 square root of x plus 8. What is that? Is your 2ab. Right? AB would just be 6 square root of x plus 8. But 2ab is 12 square root of x plus 8. Plus 9. Neck action. Do you see what happened there? All right, you guys in the back? You guys in the back right corner? I see your face, right? It says I have to poop, but you guys up in the front.
Thanks for asking.
All right. Activia. All right. So I got 4x plus, here's your chance to redeem yourself, 4 times 8. 32.
32. I literally said that like 8 times, and I'm like, why?
I was giving you a chance to shine. So if I distribute that 4, we get 4x plus 32 plus 12 square root of x plus 8 plus 9. And once again, I only have one pair that I can actually add together. So I get 4x plus 41 plus 12 square root of x plus 8. All right, so that's going to be something that we're really going to start hammering on Wednesday. So we're going to want to get that rule down. But that was only 2 of the 3 special forms, right? I've been neglecting one of them. Let's see what happens with that. So what happens then if I have square root of 5 plus square root of 6 times square root of 5 minus square root of 6? You recognize this is a plus b, a minus b, right? And that's a difference of squares. So what do we get? 5 minus 6. Why is that? Because square of a square root cancels that out. You guys agree? So if I do square root of 5 squared, I just get 5. And if I do square root of 6 squared, I just get 6. And 5 minus 6? Negative 1.
Can you say that one more time? Yeah.
So who's playing the role of A?
Square root of 5.
What is square root of 5 squared?
25. It's 5. Just 5.
It's just 5.
Oh,
Right? A
okay.
square kills the square root. Right? You could think of it as square root of 25 as an intermediary step, but I want you guys to immediately get to a square cancels a square root.
Gotcha.
And then your b is played by square root of 6. So b squared is 6. Right? Square root of 36 if you have to go through that step, but just a square cancels the square root. All right. What if we had seven minus 2 root 5, 7 plus 2 root 5. We recognize that special form, a plus b, a minus b, right? So that's a difference of squares. So what's it going to be? So close.
4 times 5.
So the 7 is not under a square root. A is played by 7, so a squared is 49. B has both inside and outside, right? The 2 is outside, so it squares to 4. The 5 is under a square root, so that squares to just 5. Does that make sense? And that winds up being 49 minus 20, which is 29. All right. What happens if I do 3 square root of 6 plus 8 square root of 2 times 3 square root of 6 minus 8 square root of 2? That's that difference of squares again, right? 9 times 6.
I don't
minus 64 times 2. Who's playing the role of A? 3 root 6. So the 3 is outside, so it squares to 9. The 6 is inside, so square root of 6 squares to just 6. Who's playing the role of B? 8 square root of 2. The 8's outside, so it squares to 64. Square root of 2 squares to 2. So we wind up with 54 minus 128. No, that's all right. Negative 74 is right. You guys okay? All right, and I've only done, what, 3 of these? Have you noticed something about this special form?
You're always going to end up with like a whole number.
Yeah. When I deal with those difference of squares, with those radicals, regardless of whether I have one radical, whether I have radicals with numbers on the outside, I keep winding up with just a number. So, that is a very special relationship. So we have a name for it. Of course. Why wouldn't we? All right, that's just what we do. Yep. A plus B and A minus B are conjugates.
Remember this word from somewhere.
Chemistry.
Maybe. So, if I gave you 2 minus square root of 3, its conjugate would be
2 plus or
2 plus square root of 3. Right? Those would be conjugates.
So you just change the sign.
Yeah, A plus B and A minus B are conjugates. Why?
Plus,
Because what happens when I multiply these two suckers together? I'll get 4 minus 3, which is a nice number. If I have negative root 2 minus root 3, its conjugate is
square root of 2 plus square root of 2.
negative square root of 2 plus square root of 3. A doesn't change, right? A minus B, A plus B. A stays the same. Is that okay?
Yeah.
So I've got negative square root of 2 minus square root of 3 and negative square root of 2 plus square root of 3 are conjugates. Why? Because again, let's multiply these conjugates together. We get 2 minus 3, which is negative 1. Do you guys agree? Is that okay? All right. So let us move to our next section, 18.6. We've added, we've subtracted, we've now spent quite some time multiplying. What's the last operator? Division. So we're going to do division of radicals and rationalization. All right, so they remind you, when we have the simplified form of a radical, that we can't have any power greater than or equal to the index. So if we have a fourth root, we can't have any fourth powers or fifth powers or beyond. If I have a square root, I can't have any squares or beyond. If I have a cube root, I can't have any cubes or fourth powers or beyond. The radicand does not contain a fraction, and no radicals are in the denominator of a fraction. So we've been mostly dealing with 1 so far, number 1. But now we're going to have number 2 and number 3. Number 2 is going to come in with division, and number 3 is going to come in with that rationalization. All right, big word. All right, so what happens if I take the nth root of a fraction a over b? Well, I can change that to its rational exponent form. So this would be a over b raised to the 1 over n power. You guys agree?
Yes.
And we know what to do with a fraction to a power. Can't we break it up piece by piece? That's a to the 1 over n over b to the 1 over n. That's one of our exponential rules. But what is a to the 1 over n? Nth root of a? And what's b to the 1 over n? Nth root of b. We actually went through this exact process with multiplication. Now we're just doing it with division. And what did we get? A radical rule. All right? So, if we have division of two radicals, we can write it as one big happy radical of the fraction, or vice versa. Right? You can either break it up to the top and bottom, or you can put it back together to make one big radical. All right? Same way that multiplication worked. So as long as it's multiplication and division, you can do a radical piece by piece, just like you could do a power piece by piece. When it's addition and subtraction, you can't do that. All right? You can't do that. Only multiplication and division work nicely that way. All right. So just to do some canned examples. If I, for example, wanted to do the square root of 32/9. All right. So according to what we had, I can't consider this simplified because I don't want a fraction in there, right? So what can I do? Break up the square root piece by piece. Do the square root of 32 divided by the square root of 9. All right? So 32, that breaks down. (16 and 2). 16 is 8 times 2. 8 is 2, 2, and 2. So I need squares. How many do I have? 2 of them. So that means I bring out 2 twice, which is 4. And I still have square root of 2. You guys agree? What about square root of 9? That's 3. Is that okay? And this is simplified. I no longer have a fraction inside the square root. I don't have radicals in the denominator. And of course, I don't have anything square or higher underneath the square root. Those are those 3 things. Is that okay? What if I wanted to do cube root of 24 over 125? And break it up. Cube root of 24 divided by cube root of 125. All right, that's what that rule says. How does 24 break down? 6 and 4. That's 3 and 2 and 2 and 2. So this is a cube root, so that means I need cubes. So I have one, so what do I have? 2 cube root of 3. You guys agree? Now, that bottom, the cube root of 125, that happens to be a perfect cube. So that's just 5. And if you don't see it, you can always break it down into its primes, and that's okay. All right? I have levels of expectations for you guys, and memorizing your perfect cubes is not quite one of them. But that's okay. You guys see what we did? This is simplified, right? No fractions under the radical, no powers above cubes, or cubes or above, I should say, and no radical in the denominator. That's the definition they gave you. What if I wanted the square root of 9x cubed over y to the 10th? Square root of 9x cubed, square root of y to the 10th. Yep, so the denominator is y to the 5th. That worked out nicely. Three x square root of x. All right, I need squares. 9 is 3 squared, so bring a 3 out. X cubed has a square in it, so we can bring an x out, but there's 1 left under. You guys agree? So 3x square root of x over y to the 5th. Are you guys okay with that? All right. So what we've demonstrated here is that you can take that radical and you can break it up piece by piece if you happen to notice that that works out nicely. We could do it in the other direction as well. But before I do that, why don't I give you another cube root? What if I give you cube root 8y to the 7th over x to the 12th? Cube root of 8y to the 7th over cube root x to the 12th. What do you get? 2y squared cube root of y over x to the 4th. Is everybody on board with that? Is that okay? All right. What if I wanted to do the square root of 48 divided by the square root of 3? So this time they're broken up, but neither one of those are perfect squares. Now, you could brute force it, but what would happen if I reverse that rule and write this as the one big happy radical of 48 over 3? Well, what's 48 divided by 3?
A decimal.
No.
It's not?
16.
Oh, never mind.
Square root of 16 was super easy. The answer is 4. All right. So we didn't actually have to go through and break down the square root of 48, pull the stuff out, and then cancel factors. You could have, but this divided cleanly, so it was in our best interest to put them together. Yep, this is using the rule in reverse. Everything in math is a two-way street. When we do one way, we can do the other way as well. Similarly, what if I had square root of 40x to the 5th over square root of 2x? Well, none of those are nice perfect squares, right? So let's just write it as square root of 40x to the 5th over 2x. Because doesn't it divide cleanly? Yeah, so we have square root of 20x to the 4th. And that breaks down to 2x squared root 5. Do you guys agree? Okay. So if it divides cleanly, it's in our best interest to put it back as one radical of a fraction, divide out cleanly, and simplify from there. Let's do one more. This one has a little trick to it. What if we had square root of 80y divided by 3 square root of 5? So I am dividing radicals, and I can put that together as one big radical, right? But who's not inside the radical?
The 3.
And where is the 3? In the denominator. So this means I'm going to write it 1 over 3 square root 80y over 5. Right? I did make one big radical out of the 80y over 5, but I had to keep the 3 in a denominator. I can't just suddenly migrate, right? What causes things to migrate? Negative exponents, and we don't have that.
The winter.
The winter. Negative exponents. So are you guys okay with that? Right? What if the 3 had been outside on the top? Well, then it would have just been a 3 outside. Right? But if it's a 3 outside on the bottom, it's a 1/3. Is that okay? And that divides cleanly. So we wind up with 1/3 square root of 16 is 4. So that could be 4/3 times the square root of y. And this is a perfectly fine answer. Or alternatively, we could have written it as 4 square root of y over 3. That's the same thing. Either of these are perfectly fine answers. Just like 4/3 x is the same thing as 4x over 3. Is that okay? So what if we level up? Let's say we have 3 times the 4th root of 243 x to the 9th y to the 6th all over the 4th root x to the negative 3y. So write it as one radical, right? But who's outside? 3. But this time it's in the top, so that means it's just 3. And then the 4th root of 243 x to the 9th y to the 6th over x to the negative 3y. You guys agree? And you see the difference between why it was a 1/3 in the previous example, because the 3 was in the bottom, and why it's a 3 here, because it's in the top. So we got 3, 4th root, 243, x to the 12th, y to the 5th. Right? When we're dividing bases, we subtract. So we have 9 minus negative 3, which is 9 plus 3, 12. And we have 6 minus 1, which is 5. Sometimes that 1 can be tricky. Everybody okay? $243 does break down. Right? If you add up the digits, 2 plus 4 plus 3, you get 9. So remember what I told you that meant? It's divisible by 3. It's also divisible by 9. So in your calculator, just divide by 9 to see what the other factor is, and what do you get? So 9 and 27. You guys agree? So that's 3 and 3. And that's 3, 3, and 3. Yep. We have a 4th power to kill off the 4th root. That means we bring out a 3, which actually makes 9. I know, I wrote it and I tricked you, sorry. Right? But we also have a 3 left under. Right? Because we had actually 5 of them, so 4 of them was a perfect 4th. 1 was extra. X to the 3rd with nothing left.
Y to the y.
Y to the
Just one y. I just have 1/4 power of it, and there's 1 extra. So 9x cubed y times the 4th root of 3y. Is that okay? All right. So that's how division works, but there was a second part of the title. This was division of radicals and rationalization. All right. There we go. So rationalizing the denominator, all right? And we're going to start off with a monomial. Monomial meaning one term, right? We're familiar with that, all right? So we refer to rationalizing the denominator when we say we want to write it where the denominator is only a rational number. So 2 is rational. Square root of 2 is irrational, right? So we don't want, essentially, radicals in our denominators. So if, for example, we looked at 2 over the square root of 3, and 2 times square root of 3 over 3. So what's the denominator of the first expression? Square root of 3. Is that rational or irrational? That's irrational. But what about the denominator on the other side? That's just 3. That is rational. Do you think these are the same number or different numbers? Let's see. If I do 2 divided by the square root of 3, I get a decimal approximation, right? If I do 2 times the square root of 3, divided by 3, what do we get? It is, in fact, the same number. Right? So those numbers have the same value. The only difference between them is one of them has an irrational denominator and the other one has a rational denominator. So that's what rationalization is. It's like a facelift. You're still the same person, right? Your face just moved up. So these are the same number. The square root of 3 just got lifted. Right? But how did I do that? Magic. No. Yeah, let's look at what happens if I took 2 over the square root of 3 and I multiplied the top and bottom both by square root of 3. Now, as long as I multiply the top and the bottom by the same value, I'm not changing the fraction, right? Up top, what is 2 times the square root of 3? 2 square root of 3. On bottom, that's square root of 3 then being squared, which becomes 3. And that's how it worked. So I multiplied both the top and bottom by square root of 3, and in that process, I rationalized the denominator. All right? So let's try one on our own. What if I give you square root of 2 over square root of 7, and our instructions here are to rationalize the denominator. What should I do? Yeah, but what do I do? Multiply both the top and bottom by square root of 7, right? So up top, that is square root of 14, and on bottom, that's 7. The square cancels the square root. You guys agree? So, square root of 2 over square root of 7, square root of 14 over 7, they're the same number, right? Facelift. You rationalize the denominator. What if I had 7 over the square root of, I don't know, let's do 5. 7 over the square root of 5. What do I do? Multiply both the top and bottom by square root of 5. So up top I get 7 square root of 5. And on the bottom I get 5. So what if I had 8 over the square root of 2? I want to rationalize the denominator. Multiply both the top and bottom by square root of 2. So up top we get 8 square root of 2, and on the bottom we get 2. But this time, yeah, 8 divided by 2 is going to reduce. So you get 4 square root of 2. Do you guys see? Right? So that one not only rationalized, it actually simplified. All right. I mean, it's not just square roots. There's another gang in town. What if we had the cube root of 2 over the cube root of 25? All right? So rationalizing still means the same thing. I don't want that radical in the bottom. All right? But instead of a square root, now it's a cube root. So what got rid of square roots? Squares. What's going to get rid of cube roots? Cubes. So this would be the cube root of 2 over the cube root of 5 squared. Isn't 25 5 squared? All right. So I have a square, but what do I need? A cube. So what am I missing? Another 5. Does that make sense? So what am I going to multiply both the top and bottom by? Cube root of 5. I'm going to multiply the top and bottom by cube root of 5. Remember, when we're multiplying, it has to be the same index. So cube roots with cube roots. Right? So up top, that gives me cube root of 10. And on bottom, that's going to give me 5. Because isn't it going to become a cube? But what happens to a cube root of a cube? That cancels out. Are you guys with me on that? So the cube root of 2 over the cube root of 25 is the exact same value as cube root of 10 over 5. The difference is, on the left, that's an irrational denominator, and on the right, that's a rational denominator. That's the process of rationalizing the denominator. Makes sense? All right, so now let's say I give you square root of 2x over 7y. So first up, break it apart. Square root of 2x over square root of 7y. Yeah, in order to rationalize the denominator, we multiply both the top and bottom by square root of 7y. All right, he was good at this. Did you guys all follow that okay? Right, if it's a square root, we need squares. Right? That means 2 7s and 2 y's, which is how we're going to get this. So up top we get square root of 14xy, and on bottom we get 7y. Is that okay? What if we have cube root of x divided by cube root of 9y? So 9 is already a square, isn't it? 3 squared. So I have cube root of x over cube root of 3 squared y. So in order to rationalize this denominator, I need to multiply by a cube root, right? How many more 3's do I need? One more. But how many more y's do I need? 2 more. Why? Because how many do I need for a cube root?
3.
I need 3, right? So I need 1 more 3, and I need 2 more y's. Is everybody on board with that? And whatever I multiply the bottom, I multiply to the top. So up top, we get
3
cube root 3xy squared. None of those are cubes. None of it comes out. But on the bottom, I get 3y. You guys agree? Because my 3 would jump up to a cube, cancel the cube root. My y's would jump up to a cube, cancel the cube root. Is that okay? What if I gave you 5 divided by cube root, give me a letter. Cube root of 3z. Right, z it is. Yeah, there's nothing hidden in that denominator this time. But if I'm going to rationalize the denominator, I need a cube root of 3 squared z squared. You guys agree? Because how many do I need for a cube root?
3.
I need 3. How many do I have of 3?
1.
How many do I have of z?
1.
So how many more do I need of each of them? 2 more. Does that make sense? You guys all agree? So if I multiply the bottom by cube root of 3 squared z squared, I'll multiply the top by cube root of 3 squared z squared. I'm not liking z as a variable, whoever picked that. That's okay. So what do we get up top?
5 times cube root 3 squared z squared.
So that's going to be 5 cube root of 9z squared. Right? Nothing comes out because those aren't cubes. And on the bottom we get 3z. Any controversy yet? Usually some people start freaking out at this stuff. So you guys are either taking this very calm or you are lying. I don't know which one it is yet. All right, what if we do 9x divided by the 4th root of 4xy cubed? And again, I'm rationalizing the denominator. So I've got 9x, and that's over the 4th root of 2 squared xy cubed. You guys agree? All right, well, what do I need to get rid of a 4th root? 4th powers, right? So I'm going to multiply by a 4th root. How many more 2's do I need?
2.
I need 2 more 2's. How many more x's do I need?
3.
I need 3 more x's. How many more y's do I need? 1 more y. So I'm going to multiply by the 4th root of 2 squared x cubed y. Neck action. Is this okay? Do you guys see why we picked this? You guys in the back? You guys on the side? All right. Yawn on my face. What I do to the bottom, I got to do to the top. So that means I wind up with 9x times the 4th root of 4x cubed y. None of those are 4th powers, so nothing comes out, right? And what do I get on the bottom? 2xy. You guys agree? Am I done? What do I have here now?
X.
Now, outside, I have x divided by x. Well, that's going to cancel out. So we wind up with 9 4th root of 4x cubed y over 2y. Do you guys see how the x canceled out on the outside? So what if we did six x squared over the fifth root of 8x squared y cubed. So we got 6x squared over the fifth root of what? 2 cubed? X squared y cubed. So to rationalize the denominator, what do I need to multiply by? Well, first off, a fifth root, right? You got to do fifth roots with fifth roots. How many more 2's do I need? 2 more. How many more x's do I need? 3 more. How many more y's do I need? 2 more. Everybody agrees. So I'm multiplying by the fifth root of 2 squared x cubed y squared. So up top, that's just going to be 6x squared times the fifth root of 4x cubed y squared. There's no fifths up there, so we can't do anything with that. And on the bottom we get 2xy. We do have an x we can reduce. And we can also reduce by 2. So this winds up being 3x, fifth root of 4x cubed y squared over y. All right. Let's do one more. Let's do one more. What if we attempted the fourth root of 32x squared divided by 9x to the 9th y to the 10th? Well, even before we break up the fourth root, we could reduce the x's, right? So I'd have 32 over 9x to the 7th y to the 10th. You guys agree? Which then I can break apart. That's the fourth root of 32 over the fourth root of 9x to the 7th y to the 10th. All right, so I need fourths, right? So this means 9 is the same thing as 3 squared. So how many more under a fourth root of 3's do I need? 2 more. If I have 2, I need 2 more. So that's 3 squared. You guys agree? How many more x's do I need? 1 more. Why? What would 1 more give me? 2 fourth powers. It would give me an 8th power, right? Does that make sense? So I need 1 more x to get up to a power of 8. And how many more y's would I need?
2.
Why would I need 2 more?
To get to 3.
Yeah, that would get me to a 12th power, which is 3 perfect fourths. Do you guys see that okay? Even if it's bigger, we can still go to a multiple. So I'm going to do the fourth root of 3 squared xy squared. So up top, that winds up being one big happy fourth root. And since those are insides, we multiply them, right?
Yeah.
288 xy squared for the numerator.
3xy.
You guys agree? And on the bottom we have 3x squared y cubed. Because how many fourths of the 3 do we have? Just one of them. But how many fourths of the x do we have? 2 of them, because it's an 8th power. And how many fourths of the y do we have? 3 of them, because it's a 12th power. Do you guys see that okay? And just because I was super evil, square root of 288, or 4th root of 288. Well, 288 breaks down into 144 and 2. That's 12 and 12. 223. 223. So for a perfect fourth, what can I break out? I can pull out a 2. That's it, right? What's left under the 4th root then? 18. A 3, a 3, and a 2. You forgot about that 2 down there. xy squared over 3x squared y cubed. Nope. Right? We just have a pair of 3's and a 2. None of those are 4th powers. All right, it's good to ask. Level up. All of these were monomials. What if I have something like 3 over square root of 7 minus 4? Now it's a binomial because I have a plus or minus in the bottom, right? So how do I rationalize the denominator here? I can't just use square root of 7 because if I multiply by square root of 7, that does kill off the first one, right? But then it just puts 1 in the second term, which is no good. So the key, it's not reciprocal, it's conjugate. What if I multiply the top and bottom by square root of 7 plus 4? Then up top, that's 3 times square root of 7 plus 4. I didn't even actually multiply it out, I just left it there. And on the bottom, isn't that a difference of squares? Which becomes 7 minus 16. So we've got 3 square root of 7 plus 4. And on the bottom, that's going to be negative 9. Do you guys agree? It does so happen that we can reduce by 3. So square root of 7 plus 4 over negative 3. So 3 over square root of 7 minus 4 and square root of 7 plus 4 over negative 3 are the same value. But the first one has a square root in the denominator and the last one doesn't. So this is rationalizing the denominator. We got rid of the square root in the denominator. So what's the key when we have a binomial? The conjugate, right? The conjugate of a minus b is a plus b. And the conjugate of a plus b is a minus b. So if I had 18 over 2 root 3 plus 3, and I wanted to rationalize the denominator. So I have 18 over 2 root 3 plus 3 times. What would I use? The conjugate of 2 root 3 plus 3 is 2 root 3 minus 3. So I'll multiply both the top and bottom by 2 root 3 minus 3. Is that okay? So up top, I've just got 18 times 2 root 3 minus 3. I'm not going to distribute it just yet. And on the bottom, I get 12 minus 9. Do you guys agree? The 2 is outside, so it squares to 4. The 3 is inside, so it just squares to 3. And 4 times 3 is 12. Meanwhile, the 3 squares to 9. Is everybody on board with that? I told you we'd be using it very soon, and here it is. 12 minus 9. 3. And that reduces the 18. So in this case, not only do we rationalize the denominator, we get rid of it altogether. All right, don't get used to that. So we have 6 times 2 root 3 minus 3. Alternatively, if you really wanted to, you could distribute, but it's fine either way. The key thing is we've rationalized the denominator. So what if we have 3 plus square root of 7 over square root of 5 minus square root of 2? And again, we're rationalizing the denominator. Yeah, the conjugate of square root of 5 minus square root of 2 is square root of 5 plus square root of 2. So that's what we'll multiply the top and bottom by. All right, so that means up top, what's actually going on?
You keep that.
Well, we're foiling it this time.
Oh, frick.
So let's go ahead and FOIL it out. Your outside, or your first would be 3 root 5. Your outside would be 3 root 2. Your inside would be root 35, and your last would be root 14. Meanwhile, what do we get on the bottom? 5 minus 2. Square root of 5 squares to just 5, and square root of 2 squares to just 2. You guys agree?
How did you distribute all of that?
I FOILed.
Okay, how did you foil all of that?
First, outside, inside, last.
Oh, okay.
That's all right. Right?
I was getting there.
Now, here's the perhaps good news. That's it for the top. There's nothing else to be done up there. None of those are like radicals. None of them reduce. Right? So 3 root 5 plus 3 root 2 plus root 35 plus root 14 over 3. And we've rationalized the denominator. No, they don't all have a 3 in common. That's it. Walk away. Step away from the rationalization. Let's do one more. Let's say that I give you 4 square root of 5 plus square root of 2 divided by 2 square root of 5 minus square root of 2. And again, we're rationalizing the denominator. What do we multiply by? Yeah, the conjugate of that bottom would be 2 square root of 5 plus square root of 2. Multiply the top and bottom by the same thing, the conjugate of that denominator. So up top, that's 8 times 5, which is 40. That's your first. Plus 4 square root of 10. That's your outside. Plus 2 square root of 10. That's your inside. Plus 2, that's your last. Everybody on board? Right. And on the bottom, that's going to be 20 minus 2. Right? The 2 squares up to 4. The square root of 5 just squares to 5. 4 times 5 is 20. Right? The square root of 2 squares to 2. Is everybody okay with that? We were practicing each of these individually. Now we're just doing it 2-for-1 special in each question. So we wind up with 42 plus 6 square root of 10, all divided by 18. But,
Does 18 go into 42?
yes it does.
Oh, God.
Well, they have a common factor of 6.
Oh.
If I factor out a 6, I get 7 plus square root of 10, all over 18. You guys agree? Because if you're going to cancel, you must factor first, right? It's one of the things we learned on our last test. We can reduce the 6 and the 18, so we get 7 plus square root of 10 over 3. So, 4 square root of 5 plus square root of 2 over 2 square root of 5 minus 2. That's all the same thing as 7 plus square root of 10 over 3. But that last one has a rational denominator. The one thing that I'm going to tell you, rationalizing, I hate to say this right before you're going to go do a lot of homework on it, rationalizing is not that important in terms of rationalizing the denominator. Where it actually comes in calculus, you're going to want to rationalize the numerator. All right, so that's out there. But it's a skill, you'll develop it.